y, a, and b. We have 4 variables, and we know none of their value, and we're given this monstrous equation that is really hard to deal with, and we want to find the least value of a plus b. And keep in mind, this is from the 2022 Aime number 12. So this is actually a really challenging problem, since we actually don't know any of the numerical values except for a is greater than 4 and b is greater than 1. These 2 constraints. Now, it's not going to be a good idea to expand. It's not going to be a good idea to expand this part and this part and set them equal, since this will actually make a lot of difficulties. So how are we going to do this problem without even solving for x and y? Well, now here's a trick. So look at these two expressions and see whether there is something special with them. And also remember the 1 right here. Even though it's not 1, then we have to divide to make it do 1. Yeah, ellipse, and more ellipse. So we have the ellipse, the equation for ellipse is x squared over a squared plus y squared over b squared is equal to 1. And this is actually an ellipse like this. So if a is greater than b, then it's actually horizontal oriented, and vice versa. So now this is actually an ellipse. So now let's actually try to look at what is going to be like, how is this, the left side is going to look like. So now we're going to actually graph it. Yeah, often if you have like this kind of problem and you have like 2 ellipse or conic sections, then it's often a good idea to graph them and see what's going to happen. So now the first ellipse is going to look something like this. And if we expand, we look at this, then a is actually half of the major axis, which is the horizontal axis. So this means that this entire length is equal to 2a. So the major radius is equal to a. Now, remember that if we have a foci, right? This length, by the definition of a foci, is actually equal to the square root of a squared minus b squared, which a is the major axis and b is the minor axis, like the half of the major axis and half of the minor axis. So in this case, a is this part and b is this part. And now we actually know a squared and b squared. So we plug into the square root of a squared minus b squared equation, then we actually get that this length is equal to 4. So what is this coordinate? -4, 0. And this is exactly the opposite with respect to the y-axis, which is 4, 0. Now we look at the other ellipse, the ellipse at right. Since actually a typical form of ellipse is actually x minus h squared over a squared plus y minus k squared over b squared. That is equal to 1. So h and k is actually the center of the ellipse. So This basically means that, let's say if its second ellipse is somewhere right here, and just use a different color like this, then this coordinate is actually 20, 11. Now if we expand to here, now looking at the equation back, we get b squared minus 1 is actually the horizontal part. This part is actually b squared minus 1 square root. And this one is actually b. So now if we just remember the foci definition, then the two foci would be located at somewhere at here and here. Just mark this point to be black. Then if we actually let's make this to be more tangible. Let's say this is f1, f2, and let's call this one to be f3 and call that one to be f4. So now we'll just make this a little bit larger. Now we look at this diagram. Okay, so the intersection of xy is just going to be a point, right? The minimum occurs at like the point. So the those of xy, they want to find what a plus b is. Now recall that if we have an ellipse and we have two foci, then if we pick a random point on the ellipse and call this f1, call this f2, and call this x, then xf1 plus xf2 is actually going to be equal, like despite of your choice at x. And when the total sum of distance, the easiest to compute, is going to be equal to 2 times the, well, it's actually it's actually just going to be the length of the major axis. This is actually a really important observation, since we know that the minimum would definitely be when the two ellipses are actually tangent to each other. And well, this definition means that we're actually just finding the sum of the length, from the point to each of the foci. So now let's actually move. Now let's say if we actually have some another ellipse like this, then for this point then this is actually one scenario, but you can see that when it's going to be when this sum is the least, and this sum is the least. Well, by triangle inequality, if we actually have two lines, then the shortest length would be directly one straight line from point A to point B. This is by triangle inequality, and this actually makes a lot of sense. So therefore, when is going to be the shortest distance possible? It means that the point must be like tangent. So this ellipse right here must be tangent to this ellipse, right? So therefore, let's call this point to be the point. Then, well, when it's going to be like the best case is when this foci and this foci are collinear, right? Since recalling this example, if these two crosses, then we have this kind of, then we actually have, move this, then we actually have something like this, and then this. And this is actually worse than the case when it's actually a straight line. So the best case would be when this is straight line and when the other two foci are also in a straight line with the line connecting them. So like this. Now we want to find, wait, sorry for the bad configuration. What? Bro. Yeah, so yeah, so now a straight line, then let's say we only look at like this line for now. Then we can actually find the coordinate of f1. So what is the coordinate of f1? So f1 is actually 20, 10, and f2 is 20, 12. Since we know the length of the foci, right? So we know the length from the foci to the center. So now we actually need, since they're actually like a line, then we just need to find the length of both of the lines. So the first line is, so now we first look at this line. Then by distance formula, it's just the square root of 20 plus 4 square plus 10 minus 0 square. That is equal to 26, equal to L1. And line 2, being the square root of 20 minus 4 square plus 12 minus 0 square, which is equal to 16 square plus 12 square, and that is equal to 20. And now, well, we need A plus B, which, what is A and what is B? Let's recall that again. So A is just the major axis of this ellipse, right? A is the major axis of this ellipse, and B is the major axis of the green ellipse, which is indeed just this part. Now, remember that A is the half of the major axis, and major axis is actually equal to the sum of the distance. So actually the sum that we found, like the sum of 20 plus 26, that is actually equal to 2 times A plus B. Since 2A is actually the major axis and 2A is the major axis of the red ellipse and 2B is the major axis of the green ellipse. Now, to find the minimum value of A plus B, we have to divide by 2. So 23 is indeed our answer to this problem. Thank you for watching, hope you enjoyed, and I'll see you in the next video solution.